We've got a little common sense with that talk. I don't know. I haven't made my decision whether the fifth grade is a common sense class or not. I will eventually. The book calls the little subheading under this with or without remainders. And then you can kind of put in parentheses that is the question. Let's do a division problem here. Here is an issue here. What if I have 50 divided by 8? And the little problem we run into here is that 8 does not go evenly into 50. How many times will 8 go into 50? So if you know your multiplication tables, 8 times what is awful close to 50, but not more than. You can't go higher than, but you want to get as close to. Chase?
6.
8 times 6 is?
48.
Okay, so 8 times 6 is 48. I subtract, I'm left with this 2. What do I do with that 2? Matthew?
You put R2
Yep. We call that our remainder. So you can just put R2 up there and everybody's happy with it. When you get to the higher levels of math, remainders are not really options, but for right now as fifth graders, that's what we're going to do. Okay, another example of that. 13 divided by 5. So I'm doing that division problem. 5 times what will give me close to 13, but not more than 13. Okay, now here's something you have to be worried for. I'll ask you here. Let's just say I'm doing this problem. I go, well, I think 5 only goes once into it. Once into it. And I do my multiplication here. I get 5 there. When I subtract, I end up with an 8. You can never have a remainder bigger than the number you're dividing by. If you do, that meant it could have gone into it another time. So I know those of you who had your hands up, you were going to say, I believe 5 goes into 13 2 times. And 5 times 2 is 10. And what's left over is the 3. I'm guessing maybe you did remainders last year, yes?
Yes.
Okay, now here is what you have to think about because we're not done with that. There are times when you don't write them. You'll have stuff left over and you don't write it with remainders. And this comes particularly when it's a story problem. And let me show you what I mean. For example, right out of the book it says, I don't know if I like that one. Sure, why not? Let's do it. 50 trading cards are to be put in, if you do this, in books that hold 8 cards per page. How many pages do you need? And unfortunately, I ran out of room, so I'm going to do this. Give me a little workspace here. So that means this. You're putting your little trading cards. You've got 50 of these little trading cards. There's a whole bunch of them. There are 50 of them. You're putting them into books. You know, maybe you have 2 trading cards. You have those little, you take the little piece of clear plastic and peel it away and stick the cards in it and flip it back down. Yeah, you've got that. So on every page, you can put 8 of them. I don't know how we split up 8. 1, 2, 3, 4, and 1, 2, 3, 4. And the question is, how many of these pages do you need to be able to put all 50 of your trading cards in there? What type of problem is that? Multiplication or division? Yeah, you're taking 50 and trying to group it in groups of 8. So you divide 50 by 8. And did we do this? I think we did this problem already. When you do that problem, what do you get? Sophia?
6 remaining 2.
You get 6, and you get a remainder of 2, but here's the gist, kids. If I asked you to give me a remainder 2 of a page, hold up your note page there. Let's say I asked Madison, Madison, will you give me a remainder 2 of that page? Could I have a remainder 2 of that? Why? Who knows what remainder 2 of anything is? It's like you can't have a remainder 2 of a person, you can't have a remainder 2 of a bus. Remainder 2 doesn't mean anything really to anybody as far as that goes. So the question, how would I answer this? Okay, the question was, how many pages do I need? Jacob? 7. One of them's not going to be completely full, but when you're buying a book, you can't get a part of a page. So when you go to the store or whatever, you're buying pages. The answer is this: you have to say, I need 7 pages. Okay, because you can't have a remainder, especially with story problems. When they ask you, you know, this and that sort of thing, you can't have remainders of a cookie, you can't have remainders of a gallon of milk, you can't have, you know, all those sort of things. So you have to watch out. Yes, when it's just a normal division problem, they give you the numbers, feel free to put remainders, but if it's a story problem, you have to be careful there. Here's another example. If you've been to a wedding, at the wedding, comma, 35 guests were to be seated, that's probably a bad idea, seated at tables of 6. How many tables do you need? How many tables are needed? So you've got these 35 people. I'll draw some stick figures. Kind of nice looking people. You've got 35 of these people, and usually they're round tables. You can only put 6 of them at a table. How many tables do you need? What type of problem is that? That's a division problem. You're taking 35 people and dividing into groups of 6. What do you get for an answer? How many times does 6 go into 35? Well,
5.
5 times, which gives me a remainder of 5. But can you have a remainder 5 of a table? So how many tables do I really, in actuality, need, Matt?
6.
Yeah, you're going to have 6 tables. Even though there's only going to be 5 people at it, you are going to need. It's a little like, you know, your car holds, a car holds 5 people, let's just say. If your car holds 5 people, and you have 6 people are going to the show, how many cars are you going to need to take? If each car can only hold 5, I mean, this is a real life problem here. You have 6 people going. You're going to have to take how many cars? No? 2. Yeah. If you take 6, divide them into groups of 5, yeah, it only gives you 1 with 1 remainder, but it, you know, unless you're going to be illegal, which I highly recommend not, because it's not worth all the tickets and all the whatever stuff going, you're going to need to take 2 cars. You've got room for 12, but you only need to fill up 5 of them. That is the way it goes. Such a goes in the world.